This will be a little bit more about connectivity, a little bit beyond embedded building, but also how to support embedded products in the field. So hopefully you will find it interesting. Just a quick background about me. So I'm one of the co-founders of Mender IO. I have about 10 years in system security management and background from cryptography. And you can see where you can reach me there if you have any follow-ups or questions after the talk. Mender IO itself is a way to manage software on connected devices. It's got an open source core, and there are some add-ons for device management beyond OTA as well. So why should we talk about remote access? So since we're working in IoT and supporting IoT product vendors and OEMs, we see this as a very common need. We did quite a bit of research on remote access recently, and technical feasibility as well. It's around 30 interviews and service people from users, basically what's needed to support or to do remote access. So what I wanted to do today is to share the findings from the research so that, yeah, whenever you come across this use case, it can save you some time and avoid repeating work that has already been done, basically. So in terms of the agenda, I'll just quickly introduce remote access and then look at the requirements, specifically in IoT or connected devices. And then finally, we'll take a look at a few different approaches to doing it. And obviously, we are working on this in Mender, but I'm not going to make this Mender specific. It's more about the technology. So what is remote access? So just see if you can recognize this sequence of events. If you have a product that you're selling to customers today, that is being used. So first off, your customer will tell you it doesn't work, not very descriptive, right? But something is wrong, so you have to ask what's going on here, what's wrong. And maybe the UI is hanging, but of course it works on your product, right? So you don't know exactly what's different. And the documentation was followed, so it should work. And then maybe the next step is that you try to get some more information from the device, right? So you ask the user to collect some process, maybe log files, data, and so on. But of course, the problem is that customer doesn't necessarily understand what all this means or how to do it. Maybe there's insufficient data that's being submitted. And this cycle can go on for quite a while, and then the product doesn't work for the customer, and it's annoying for you to support it this way, right? It takes quite a lot of time for everybody. So that's the motivation behind remote access, because in the scenario where you have it, you would use it to troubleshoot and hotfix issues supporting coming from customer support primarily. That's typically the case where it's a reactive scenario. But it could also be that you have monitoring set up, so you know a device goes offline or there's something wrong with it, so you want to investigate it further. And you can also use it to do ad hoc changes to like pilot devices if you have 10 customers testing out the beta or pilot that you have just released. And it's almost always just about one device at a time. And to put it in context, at least what I would consider device management consists of being able to do over-the-air software updates to quickly and safely improve the product, configure the device to customize it to each environment. This could be to, for example, set the time zone or things like that that are not uniform across all devices. Typically OTA software updates, this would be like the same for all the devices, but configuration allows you to make some unique changes. Then we have remote access. This purpose is mainly to resolve support issues real time. And monitoring, I think, is the last piece where you can detect and analyze health issues. So this is a more proactive way than customers reporting issues. Of course, you will have both cases. Okay, so if we look at what's needed in IoT, what are the requirements for remote access? At least those that we found is typically you'll need the ability to restart an application when something, when it doesn't perform or it hangs. Typically that's the first step, or maybe even restart the entire device. And you would like to run some diagnostics tools to investigate further, maybe some debug tools, and analyze applications and system log files, kernel logs, or syslog applications usually could be logging to systemd or some other service. And maybe you also need to access some local services on the device. This could be admin portal. If you have a Wi-Fi router, which I think most of you have, and you try to log into the local IP of it, you will get this kind of portal. And we've seen that quite a bit also in IoT, especially consumer devices, that there is some portal that the end user can use. And using remote access, you can also log into that, even though it's only locally accessible. And you can also test connectivity as it's seen from the device. Maybe you need to connect to some backend service and see what the response is if you are as if you are on the device. So those are the main ones. And to cover this, what tools can we use? Typically for the first three, you would use a terminal. So this is the core tool for every developer. And you can do all this: restart application device, run tools to diagnose, and also look inside application files or log files. But if they get too heavy, it might not be possible to do like real time. So that's why you would need file transfer as well. If there are bigger files you need to collect from, or maybe core dumps even, from the devices, you would need to copy that file from the device to your laptop, for example. And also, in order to run diagnostics tools, it's useful to copy the other way around, like GDB or any kind of debugger. Typically, you don't have those installed in production devices, and you don't want to install them on the system level. So copying back and forth is useful for these reasons. And of course, the last one is port forwarding. That allows you to access services running on the device, even if they are local to the device. So this is the summary. Terminal, file transfer, port forward, those are the core features we identified, at least that's needed. And those should be a bit familiar to you already through tools like SSH and SCP, because they cover these exact use cases as well. But if we take a step back and we look at how like connected devices, IoT, what's the environment they live in? So it's typically quite remote, hard to reach physically. It could be industrial machines, or in consumer homes, you can't really go there and do something manually to each device. That's how it's been done historically, but when you scale up, this doesn't work anymore. And they're expected to live for quite a while. I think the lower end is probably consumer devices, around 3 years. Industrial can be like 20 or even more. I'm sure many of you are familiar with that challenge in supporting long-term Linux kernels and other software. But the network can be quite difficult to work with. You can have intermittent connectivity, wireless devices move around, lose connectivity, and only outbound connections typically, for the same reason that you don't have public IPs on these IoT devices typically. And you should assume it's insecure, and in many cases it has low bandwidth as well. And power is unreliable, so it can be unplugged at any time. So the first two makes remote access more important, whereas this one, the unreliable network, makes it more difficult to implement. So we'll take a look at some of the approaches there. But in terms of summary for the network, which is what we need to keep in mind for remote access in order to support it, is that only outbound connection needs to be secure end-to-end. So authentication, encryption are key there, and also zero open ports is typically a requirement, at least from the users we speak to. It's not necessarily a vulnerability to have an open port, of course, on the device, but if you're not careful, it could lead to some problems, let's say. And then low network overhead. Okay, so assume we have all this. That's still not enough, unfortunately, because the vendor gets pretty wide control here, or you as the vendor maybe, to the customer's device. So assume we have the same scenario, but now you have the vendor has remote access. And what could happen, of course, is that the vendor finds something interesting there. Hopefully not credit cards, but could still be sensitive data, especially in terms of privacy. And who knows what the vendor will do here for the employees working at the support. So what we also need is what I call operator security. So we'll need some audit logs. So what did the vendor do? And which one of their employees did it? When and which devices? Also for the terminal in particular, session logging is very useful. So you keep a complete history of what's been done on the device. And approval of access. This enables the customer to approve that somebody's trying to log into your device. Now, do you accept it or not? So it's not always on for the vendor. And finally, role-based access control. So that not everyone having access to the server, let's say, can access all devices, but you can limit it to groups of devices based on the customer, for example, or geography, and also the user, the vendor's employee, let's say. Not everyone should be able to use remote access. And the last one is you can, of course, limit which user is being allowed access to on the device side as well. So if we summarize it, 3 main features: terminal, file transfer, port forward. We have to take into account that we can only do outbound connection. Needs to be end-to-end secure, low bandwidth. And then for security and privacy of the end user or customer, we need to have audit logs, approval of access, role-based access control, and device side restriction, especially in terms of the user that's allowed to, or yeah, what the user at the device is allowed to do. So with that in mind, let's take a look at what we can do here. So obviously there's a lot to worry about. But if we look at the two most restrictive requirements first, or two most difficult ones, and we start there, we can try to see how we can build further on these other requirements. Because I think if we can solve the terminal and outbound connections issue, we can probably build something on top of that. So that's where I would start. So how to access the terminal on a device that only has outbound connections. From the interviews we did, how it's being done today, majority uses VPN SSH. I'll go through these afterwards, but there are some other alternatives too, like raw socket, WebSocket, reverse SSH, and yeah, some dedicated products to do it, like remotely. This one. So if we look at the VPN option first, so this, as you probably already know, allows for inbound connection on an overlay network. So yeah, it creates a network on top, which on top of the yeah, network you have, that allows inbound connections. So from that point of view, it removes this outbound connection requirement. And it's very well-known technology, especially in cloud and desktop. You see it everywhere in enterprises in particular, to segregate networks and give access to internal systems. And there are several open source implementation as well. A newer one, I don't know if you call it new, it's many years in the making as well, but in this field it might be new, is WireGuard, which seems to be a bit simpler implementation, easier to get going with. But we also have the well-known one, OpenVPN, which you probably also are familiar with. But this one is, at least to me, quite challenging to work with. The other option, reverse SSH, it works in this way, just as a reminder. So your device would then set up a tunnel, a persistent tunnel, to a public server, and it would expose itself on a port on that server. And then whenever you need access to that particular device, you would create a tunnel inside. So you would connect to the public server on that port, and then that would be tunneled to the device. That's how it works. It's conceptually similar, I guess, to VPN. And if you compare it a bit, it's definitely easier to set up, because you run a command on the device and you run a command on the laptop. Yeah, you need some server, but that's not too hard to get these days. So it's quite easy to get going, but it's quite difficult to maintain, because now you're going to have a bunch, if you scale it up. So it's like for one ad hoc case, this might be okay, but if you're trying to support a fleet of devices in the field, this I don't think it will work, because now you have a range of ports on a server somewhere that you need to connect to. You need to make sure that the devices keep the connection open, keep it alive, and so on. So it's quite a lot of maintenance involved here over time. So that's why I would not use this in production for yeah, smaller scale POC pilots, hobby projects, perfectly fine, but larger scale or production devices, I wouldn't do it. But rather use VPN, for example. For raw sockets, this is completely application dependent. So this is something you would develop from scratch. So you just create a TCP connection from the device to some service that you also develop. And then, yeah, you develop remote access from there. So then server side needs to keep the connections alive and let users use them as they are needed. Of course, it must go through a secure channel due to the network requirements we had. This will be TLS. I don't see any other options that are viable, but still this is pretty well-known technology. And this would be, in the end, a completely custom implementation that you would make yourself. This I would also not do because of yeah, what's coming. So the fourth option is WebSockets. Some of you might have heard about it. Most cloud application developers, or especially like UI developers, have heard about this. But I'm not sure in embedded if it's used that much or doesn't have that much adoption. But it's also a quite old specification, about 10 years. And it has already wide client and server support. What it does is that it's an extension to HTTP, actually, or yeah, you could say HTTPS also, but that's just a transport layer security. So on top of HTTP, it allows bidirectional communication by performing a connection upgrade. And since it's on top of HTTP and it's standardized, it is also traversing firewalls quite easily if you're in that situation, which many are. And since it's also HTTP standard, it's there are support for proxies and reverse proxies here as well. It takes care of connection management, so it does health checks, make sure connection is alive, and yeah, does keep alive messages as well. Then the last option is off-the-shelf solutions. They typically, so these are products basically that cover remote access. They have good use case coverage, probably more than what I mentioned earlier. Yeah, Remote It was one we found, and Mender has Troubleshoot add-on package as well that covers some of these use cases. But there are lots of them, so if you just Google for like IoT, remote access, something like that, you'll mostly get ads, but there are some products there as well. MQTT, just a quick note, since it comes up so much in IoT. So this is a messaging protocol. So why not use that? It's publish subscribe model, but WebSocket is a transport. So so MQTT is a bit more than WebSocket. It's formatting of the messages, and you can send messages to many devices at the same time. WebSocket is just a raw binary stream, basically. So it's only on the transport level. So if you have it, you could use it, but it's probably more than you need for terminal access, for example. So if we take one step back, we solved a couple of two of the main requirements in different ways, or they can be solved. I am going to skip looking at reverse SSH raw socket because they are better covered by other solutions like VPN or WebSocket. So if we look at the total use cases I mentioned and requirements earlier, this is how the coverage is for VPN SSH. It will cover, yeah, the core use cases. You do have one port to worry about on the device. If you configure it correctly, it will not be exposed on the local network. But if you don't, it might. So you have to be a bit careful. And there are more credentials. You need to have VPN certificates distributed and so on. And it requires a bit more bandwidth because now you're running a SSH tunnel inside a VPN tunnel. It doesn't out of the box come with any audit logs, access approval, role-based access control. You can build these things as well. They're not that easy to build. But you can, of course, restrict the user that's used on the device would allow users in SSH. So WebSocket looks a bit similar. It covers the main use cases, but you don't have an open port at all on the device because it's always initiated by the device. And the bandwidth is a bit lower because yeah, you don't have a tunnel in a tunnel basically. And the other use cases can also be implemented here. They are somewhat similar complexity regardless of if you use VPN or WebSocket, I think. This is an example architecture of WebSocket. If you're new to it, maybe it's interesting. This is the one we use in Mender. So the way it works is we have a service on the device that connects to a cloud service. And it upgrades the connection to WebSocket. Then users with a laptop or through a web UI can also connect to the same service. And then there is a simple message queue that kind of bridges the two between the device and the user. And then you can also, or at least in Mender, we have audit logging in place so you can see what's happening in that connection as well. For example, which terminal commands are sent back and forth. And of course, yeah, you need to authenticate these users so they're not wide open and have role-based access control and so on. But this is how basically it could work if you decide to go with a WebSocket-based architecture. And the thing to think about also before you go on this journey of implementing remote access is what do you have already? Maybe you can just reuse a VPN connection you have. Be careful with the open ports. If you have MQTT that's secure, you could build at least a terminal. I'm not sure about the port forwarding. And if you have credentials like TLS keys, you could use those for WebSocket implementation and also others. If you have nothing, I would definitely go with the off-the-shelf solution instead of starting from scratch. So my main message is to try to reuse as much as you can for this, because at least what we discovered is trying to build a remote access solution is more complicated than you would think. I guess this applies to most engineering projects, but this one in particular, you cannot do it wrong because it can have very bad consequences and expose devices to vulnerabilities. So consider the last slide, what you have already, something you can reuse, and off-the-shelf solutions built for IoT. This would be my my last comment, because then you can spend your time on developing what you really want to do instead of maintaining all this infrastructure, which can be quite a bit of work long term. And with that, I am done with the presentation. So thank you for having me, and thank you for listening in.